account hierarchy. And the service that dictates that is called AWS Organizations. Within AWS Organizations, this service is provisioned within the management account, what used to be called the master payer account. It's no longer called that. That account is responsible for all charges of the accounts that fall underneath of it, and also has the permission to set access control and policies for subordinate accounts. Underneath of the management account, we can create organizational units, and this is all done through AWS Organizations. So we might, for example, have Team A and Team B that we want to have separate policies on and have different accounts fall under different organizational units. It could be different products, so in this example, Product 1 and Product 2, or different departments, Department 1 and Department 2. Really depends on the organizational structure of your corporation and how you want to build and control these type of policies. Underneath of each of these organizational units is where the accounts fall. So you might have account 1, account 2 in Team A, account 3 in Team B, account Y in Product 2, and account Z in Department 2. So this is our AWS accounts. An important point to remember when you think about AWS and how they've designed things, there's a very strong account construct. So the resources actually live within an individual AWS account, and it's not something that you can just add to another account. So we'll see what type of resources those can be, but just keep in mind that account is a pretty strong boundary, and any resources you need to access from outside the account, you'll need to end up doing some type of sharing. All of the AWS accounts and services, and like we were just looking at AWS organization, all live in the AWS management console. You can see here there's quite an exhaustive list of products and services that AWS offers. And actually, if you were to find the main one that we're concerned about in this training, the VPC for networking, you'd have to actually scroll down quite a bit to get to the VPC, the virtual private cloud. There's also a search bar that they've added recently, which you'll find quite helpful as you navigate through and try to find the specific service that you're looking for, and then you can pin it so it's there for you to see. So if we went and clicked on the VPC console, the virtual private cloud, we would be greeted with this screen where we can see by region all of our VPCs, subnets, route tables, and resources that we have that we can manage. And we'll get into talking about what regions look like with AWS and what some of these concepts mean. Now, if we were to click, for example, on our VPC tab, we'd be directed to this screen where we can see all of our VPCs in the region. We can see a quick summary of their CIDRs, their route table, and the network access control lists that are associated with them. Again, we'll get into what all those constructs mean. Some important services that you definitely will need to keep top of mind as you work with AWS and study is IAM, primarily for identity and access management. Any access to any APIs or resources or actions taken within an AWS account, all are governed by IAM, the identity and access management. So that's the central service, and that is a global service. So if you, for example, create an IAM user, that is a global entity across that AWS account. Within AWS accounts, there's VPCs, virtual private clouds, and these are your portion of the AWS network that you can carve out. Think of VPC as the overlay network that AWS allows you to create. There's EC2, Elastic Compute Cloud. This allows you to create instances, and an instance is just how AWS calls their virtual machines, essentially. So the ability to run a virtual machine, which would be within a VPC. Another is S3, the simple storage service. This is a pretty fundamental object storage, and it was one of the first services AWS released. So you can create buckets. You may have heard someone say an S3 bucket or something to that nature. And in fact, as you're browsing around on the internet, you'll find a lot of that content actually happens to live in an S3 bucket. There's Direct Connect, which is a private fiber path to the AWS network, to the home region that you need to connect to. And this is done using virtual interfaces, or VIFs as they're called. And this is just a standard 802.1q VLAN trunk that gets tagged on a layer 2 interface that you interact with the provider on. So there's a few different types of these VIFs. There's a public VIF. This is used to connect to Amazon public networks. Amazon will advertise all of their public IP space at you, so you see a few thousand routes. There's a private VIF. This is used to connect directly to a Direct Connect gateway or a VGW, and we'll get into what those are. And then there's a transit VIF, which is the newest type of VIF, which is used to connect to transit gateways through a Direct Connect gateway. And Route 53 is a cloud-scale DNS solution providing both public and private DNS resolution. Getting into some more networking components, you'll notice a lot of the AWS design is modular. So there's these gateways. There's an internet gateway to provide internet access from a VPC. There's a NAT gateway for instances in a private subnet to get access out to the internet. And it allows instances to initiate connections only outbound. So downloading software and patches, it doesn't allow any type of inbound connectivity. There's a transit gateway, TGW. This is a network transit hub that can interconnect VPCs and on-premise networks. There's a virtual private gateway, coincidentally called a VGW. It's a virtual gateway, and it allows connections for site-to-site VPN tunnels to a specific VPC. It can also be used to connect to Direct Connect to a VPC, and also a Direct Connect gateway as well as a private VIF. There's Direct Connect Gateway. This is a global logical entity that allows you to connect a Direct Connect virtual interface, a private interface, or a transit VIF to your Direct Connect. And they can be anywhere. It's a global construct which allows you to connect from any AWS region to any type of on-premise location. There's also a customer gateway, a CGW, and this is just what AWS calls the on-premise router equipment that you connect the virtual gateway, transit gateway, or Direct Connect gateway to in your on-premise location. Or it could be a cloud location, depending if you're running services in the cloud. So let's take a look at what this looks like when you think about the AWS networking architecture. To start off with, there's the AWS cloud, which spans the globe. Within the cloud, you'll be working within a specific region. Most services are regional and scoped to a specific region for both high availability and availability. There's a strong isolation between regions to facilitate that minimized blast radius. So an example, I'm closest to Northern Virginia, so US East 1 is what they call the closest region in Northern Virginia. Within a region, you can build VPCs, virtual private clouds. And you own the topology here. You can control the CIDR addressing that you'd like to use. And you control the network environment. So you can see here I've specified an IP range. You create subnets within that. You can manage route tables and gateways and all of the connectivity options. Within a region, AWS has the notion of availability zones. It works a little different between some of the other providers, but in AWS, it's a strong isolation where availability zones are one or more discrete data centers that have redundant power, cooling, networking connectivity, and they also ensure that those AZs are on separate floodplains. So really minimizing the blast radius where if for whatever reason there was a problem in one availability zone, the other availability zones in that region would be up and functioning and not be affected. Obviously, an act of God could take out an entire geographic location, in which case you have a multi-regional architecture. Within the VPC, you provision subnets. You can have one or more, and these subnets can either be public or private. A public subnet has a direct route out to the internet, whereas a private subnet does not. It goes through some type of NAT or NAT gateway. Within a subnet here, we're using a private subnet. You can deploy a EC2 instance. And when you deploy an instance, it automatically uses DHCP to get an IP address from that subnet CIDR. So here we can see it's gotten 10.0.1.50. Every instance that you deploy has to have one or more security group, at least one. And a security group is a stateful firewall that kind of surrounds an instance. So for example, if we don't allow outbound access at all, there's no getting out to any resources. But at the same token, if we allowed port 22 into that instance so we can SSH in, it would automatically allow the return traffic because it's stateful. There's no way to obviously to add deny rules in that type of instance. There's an explicit deny if there's not an allow rule. We can take the same subnet and the security group and apply that security group to multiple instances within the VPC. Here I'm just showing two different subnets. And important point to remember, though, is that those security groups can't be scoped outside of a VPC. You can't associate with a VPC in another region or within the same account for that matter. And then we can have multiple security groups. Here we have a separate one for the private subnet in availability zone B as well. We have an additional layer of security that we can configure as well called a network access control list. These allow deny rules. They're fairly limited on how many we can do, but they're scoped to individual subnets. You can only have, or you can have multiple of those, and that controls the traffic. An additional layer of security there, if you wanted to specifically allow traffic or deny traffic, they are not stateful. So if you, for example, wanted to open up port 80 out to the internet, you'd have to allow all of the ephemeral ports, the few thousand ports, to allow that incoming traffic to be able to traverse. There's a few different types of gateways. We were talking about the internet gateway. This allows inbound and outbound internet access. The virtual private gateway, this allows connectivity to a VPN connection or a direct connect connection to allow for hybrid connectivity to on-premises. We see a router here. There's actually an implicit router within the VPC. So when your instance comes up and gets an IP address, it'll also get information about the default router and be able to route traffic. This routing is controlled by route tables, and route tables are specific to a subnet. So you can see here we have a separate route table for the public subnet and another route table for the private subnet. And those route tables look fairly simple. There's a destination and then a target. And we can see here we also have a NAT gateway. This is a service that AWS provides that does the NAT address translation for you so you can have outbound internet connectivity. So my bottom instance on the left here can actually route out through its default gateway, and that'll hit a route table. And then here we can see I have a default route that points to a NAT gateway. So that traffic will go to a NAT gateway. And from the NAT gateway, that traffic will hit the route table, and we can see there's a default route out to the internet gateway. So that allows that outbound communication, and obviously it's tracking the connection to allow the inbound connectivity for the two-way communication for the flow. So we refresh here and dig in a little more on some of these concepts. The internet gateway allows the inbound and outbound access from the internet. There's a virtual private gateway. This allows VPN connectivity and also direct connect connectivity. There's availability zones. This is one or more discrete data centers in which infrastructure is deployed. And then there's public subnets with a route out to the internet and private subnets that do not have a route out to the internet. Then we have route tables. which allow us to control where traffic is going and how traffic is routed. There's security groups, which provide control over instance networking. It's a stateful firewall. We also have NACLs, which are stateless, which allow you to deny rules in addition to allow rules and have granular control over traffic. There's network interfaces. This instance that we see here, this 10.0.1.50, it's actually the IP address of the network interface. They're called an ENI, an Elastic Network Interface. We can do NAT. AWS provides a NAT gateway service, or you could spin up a NAT instance. If we look at, for example, at a NAT gateway, we can see we have a private IP address, which is from the VPC CIDR. We also have a public IP address that is assigned by AWS. And in the case of a NAT gateway, it's what's called an elastic IP address. And an elastic IP can be disassociated from one resource and associated to another. It's also a static IP for the lifetime that you have it provisioned. It won't change on you. It's not going to go away. That's in contrast to a public IP address, which if you launch an EC2 instance and specify the public IP address option, it'll automatically get a public IP address from the AWS pool of available IPs, but that's a transient IP address. If you were to restart or stop that instance, that public IP address goes away. And every resource in a VPC has a private IP address. We can see that here. Both the NAT gateway and the instance have a private IP address. Let's get into one of the native AWS networking constructs called VPC peering. This primarily allows VPC to VPC communication. One important point here, though, is it's not transitive. So VPC A and VPC B can communicate with each other, as well as VPC A can communicate with VPC C, but B and C can't communicate with each other. It's not transitive. So you need full mesh for any-to-any connectivity. This makes it difficult to insert firewalls. It comes with some scalability challenges. There's a hard limit of 125 peers, but you certainly wouldn't want to be managing a network at that scale using VPC peering. It quickly becomes kind of a nightmare. And there's some other constructs we'll look at that are better suited for doing this at scale. It is a great option to be able to quickly connect together VPCs within the same region. It also works between regions as well. Another construct that was more recently introduced is called AWS Transit VPC. And this is, you can think of it as a cloud router, a basic cloud router that provides interconnectivity between VPCs and Direct Connect. We can see here what that kind of architecture looks like, and we'll get into the components. So some things you need to manage here. The VPC route tables aren't actually updated at all by AWS or these managed services. So you need to manually update those route tables to include routes, especially if you're learning routes over BGP, through Direct Connect or VPN. And the way that you connect to a transit gateway is called an attachment. Here we can see there's VPC attachments. There's also a Direct Connect gateway attachment, which allows connectivity through Direct Connect to on-premises. And you can do VPN connections as well, a VPN attachment. There's route table associations. The transit gateway supports different route tables, kind of like a VRF in a traditional router, to allow for segmentation. When you deploy a transit gateway, it allows default any-to-any communication, so you probably want to go in and add some segmentation there. But you quickly find that there is a limit of 40 segments, so that type of segmentation is limited in its scale. Some challenges with a single transit gateway. First and foremost is route limits. So if you have a direct connect and you're connecting to your on-premise location, it could be a full 10 or 100 gigabit direct connect connection. You're only allowed to advertise 20 CIDRs from the direct connect to on-premises through the transit gateway through the direct connect. gateway. From your on-premise routing equipment, the Direct Connect gateway can accept 100 routes that will advertise to the transit gateway. If you advertise more than 100 routes, you'll find that things start to break, BGP flaps, and your connection goes down. There's manual VPC route table management here. So if I learn a new route from on-premises, I need to update each and every VPC so it can route to that on-premise location. And also the 20 CIDR limit means that I need to do some type of route summarization or some type of strategy if I have more than 20 VPCs that I want to advertise to on-premises. There's also no automatic VPC CIDR summarization. You have to manually go in and specify these CIDRs to advertise to on-premises. And then you don't get any type of way to have visibility into those BGP attributes and monitor kind of what's being allowed through the network. There's also a limited layer 4 to 7 firewall insertion, some pretty complicated deployments which are difficult to manage and come with some performance limitations. So things to keep in mind as you look through that. Some additional challenges with multiple transit gateways, probably first and foremost, is there isn't any ability to do intra-region transit gateway peering. And actually, I heard this a lot when I was at AWS. Customers wanted a dev transit gateway, a prod transit gateway, and wanted to peer them together. It's just simply not possible today. There is support for inter-region peering, but this actually brings some challenges in and of itself in that there's a manual process. You have to statically add routes and target them at the inter-region peering connection. So especially at scale, this can become difficult to manage. If you have tens of hundreds of VPCs connected to a transit gateway that you want to be able to communicate with each other. And those routes aren't propagated. Each region is essentially its own island. And there's no overlapping IP support here. Overlapping IPs cause some problems there, and there's some hacks out there to get around it, but it's really not a production-ready solution. If we take a look at the transit gateway visibility and troubleshooting, it's actually pretty isolated. There's no end-to-end network visibility. It's only aware of its direct attached entities. So it's not aware of interaction of within a VPC, the route tables, the internet gateways, any NAT gateways that may or may not exist. There's also no visibility into other network elements within a VPC, be it the other transit gateways, the VGWs, the virtual gateways on the VPC, VPC peering, and PrivateLink as well. So there's an additional layer of management that needs to be done there. It is a black box, so there's not much visibility that you get built in, and there's an inability to use some common troubleshooting tools like ping, traceroute, and telnet. It simply just doesn't respond to those type of requests. You don't have that troubleshooting capability, and there's no type of NetFlow support for data visualization and monitoring. In terms of BGP support, it can become difficult to bug BGP capabilities and options that you have enabled. It also doesn't pass any BGP attributes to peers. It doesn't show the attributes that it does learn in the route table either, which from troubleshooting can become difficult. And from cloud to on-prem, the Direct Connect gateway only allows manual CIDR config through what are called prefix lists, and you don't get to choose any attributes of BGP there. Let's get a comprehensive architecture here. We have a customer gateway on-prem that has a direct connect connection. We can have a public virtual interface. This allows us to connect to all of Amazon IP space. They'll be advertised to us, a few thousand routes. So good for connecting to things like S3 is a pretty common use case, and connecting to public AWS services that have public IP addresses. There's a private VIF, and this can be connected either to a direct connect gateway, which can then connect to a virtual gateway of a VPC in any region. There's also a transit VIF, which can be used to connect to a direct connect gateway, and it's a special type of VIF that can only attach to transit gateways. So here we can see this transit VIP allows us through a direct connect gateway to connect to transit gateways, and those can be in any region around the US that supports transit gateway. And we can connect to up to 3 of those to a direct connect gateway. You can see here kind of what that looks like. So hopefully this was helpful module. You can learn more here on both these 2 YouTube videos about